All right, boys and girls, so today we're going to be going over Unit 3, Lesson 4, which is interpreting solutions to inequalities. That means we have to try to figure out what our solution or what our answer to the inequality represents. Let's start off by looking at the do now. All right, make sure again that you write your name at the top first. It says solve and graph the linear inequality below. So the first thing we always practice doing is drawing our train tracks. So I'm just going to drop a line here, and then we're going to just start solving the inequality. So if I look at the left-hand side right off the bat, this looks very busy, and I have some like terms that I can combine. That's always the first step to see if you can distribute or if you can combine like terms. I see that I have a negative 3x. I also have a negative 5x. Those are like terms. I can put those together, and when I combine, I get a negative 8x. All right, that plus 7, I just bring it down. And then the 15 on the opposite side I bring down as well. All right, and now I just continue solving from here. I don't have any more like terms, so now I'm gonna go to opposite sides by doing the opposite operation. So I can combine 7 and 15, so I'm gonna bring the smaller number to the bigger. The opposite of adding 7 is subtracting 7. So I'm gonna subtract 7 on both sides. All I have left is a negative 8x. 15 minus 7 is 8. And then last step, if I want to get x by itself, well, right now x is hanging out with that negative 8. When I have two numbers that are mushed together, I know that represents multiplication. So the opposite of multiplying is dividing. So I'm going to divide negative 8 on both sides. That cancels. So now on the left-hand side, I have an x. And on the right-hand side, 8 divided by negative 8 is negative 1. And I have to ask myself when we were learning in lessons 1, 2, and 3, right? When you divide by a negative, because I divided by a negative 8, the inequality flips around. So instead of having the less than symbol, I'm going to change it so it looks like the greater than symbol. All right, so that's going to be part A, just solving the inequality. But it also says to graph, all right? So we have to solve and we have to graph. So I'm going to start off by putting my solution on the number line first. So I'm going to put negative 1 just right in the middle. You can put it anywhere, but I know we like to start in the middle. If I were to get bigger, moving to the right-hand side, the next would be 0, after that would be 1, then 2, so on and so forth. If I'm getting smaller, I'm going to the left-hand side. This is a little bit tricky. Next would have been negative 2, then negative 3, then negative 4. I'm getting further away from 0, so this is what my number line should look like. And then going back to what we've been practicing, this would be an open circle on negative 1, open. And my arrow is pointing to the right-hand side. So I'm going to, again, have an arrow that points to the right-hand side. And now I have solved and graphed in part A. Now, part B is going to be new. It says, using your graph, determine the smallest possible integer x can be. That's really tricky here, the smallest possible integer. So negative 1 would not be a solution because it has an open circle. That means it is not included. So what's the next integer, that next whole number that I can pick from? Well, if I follow the arrow, whoop, I end up at the number 0. So when it says what's the smallest possible integer, the smallest, write this out with me, the smallest possible integer is 0. Because I can see my arrow goes to the right, so I could be 0, that would work. I could be 1, that would work. 2 would work. 10 would work. 1,000,000 would work, right? All these numbers would work, but which one is the smallest? Well, 0 would be the smallest. It's smaller than 1, it's smaller than 2, it's smaller than 1,000,000, all right? So that's why 0 would be the answer. So the trick here, you just follow the arrow to the next available number, and that's your answer. So if we look down here at our notes, this is what we're going to do when we're solving questions like this. The first step is you want to solve the inequality, all right? Remember to change the direction of the inequality if you multiply or divide by a negative. I'm actually going to highlight that because it is super important. You have to change the direction of the inequality if you multiply or divide by a negative. That is huge, okay? And then after you finish solving, just like we did in the do now, Down here, oh, so sorry guys. Down here it says analyze your solutions. So if you have a less than symbol, right, less than, you want to look to the left of the number line. If you have a greater than symbol, that means you want to look to the right of the number line, because I can always make a little arrow out of those inequality symbols. If A is less than or equal to, then my answer should equal A. Okay, and the same thing, if I'm greater than or equal to, my answer should equal A, because I can either be A or greater, I can be A, or I could be less. All right, let's start off by looking at this example here. So the first step, like always, is to drop our train track. Whoop. Okay, now I'm gonna go back, and as I'm looking at the left-hand side, this looks pretty busy, so I'm gonna see if I can distribute or combine like terms to start. Well, -2 and -7 are numbers, and I can always combine those numbers. All right, so -2 minus 7 is -9. I'm going to bring down that minus A, and that's going to have a -12 on the opposite side. And then I just keep solving from here. I don't have any more like terms, so now I want to start going to the opposite side by using the opposite operation. I'm going to combine 9 and 12 by bringing that -9 to the opposite side by making it a +9. Opposite side, opposite operation. So that cancels out. I have a -A. And then -12 plus 9 is -3. I really have an invisible -1 in front of that A. So if it's helpful for you, I would draw that in. I know that it helps me, so I would add it on. Okay, when you have a number and a variable mushed together, mushed is multiply. So the opposite of multiplying is dividing. So we're going to divide both sides by -1, because that's my coefficient out front. These cancel. So now I have the variable A. -3 divided by -1 is +3. And then ding, 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 here we go. I divided by a negative. When you multiply or divide by a negative, you have to change the inequality. You got to change the direction. So it's not going to be greater than anymore. It's actually going to be the less than symbol instead. All right, so in all of the other lessons, this is where we've been stopping, but always reread the question. You have to make sure you answered it. So it says, determine the largest integer value of A. I'm going to underline that. Determine the largest integer value A can be. So you can either do this one of two ways. You can draw a number line, which I'm going to do right now. So I'm just going to put a number line here, and I'm just going to put one number on it. I'm going to make it the solution, which was 3. Okay? 3 would have an open circle. That means it is not included as a solution. And it looks like my arrow would be pointing to the left. So again, I'm just going to shade here to the left-hand side. So again, 3 could not be the largest integer because it's an open circle. It's not included. So now I have to ask myself, what number comes right before 3? What number would be less, because I'm going to the left-hand side, what number is less than 3? And you guys got it, it would be 2. So you can either just think about it mentally, or you could fill out the whole number line if you wanted. 3, 2, 1, 0, right? And then I hit my negative numbers. So since 3 doesn't work, the next available integer would be 2. All right, so what's the largest integer value? 2 is the largest integer value. All right, make sure you guys are adding this to your notes. If you don't have this little blurb at the end, you haven't answered the question completely, so just be careful. All right, let's go to the next page here. All right, so as we look at number 2, that's really all we're practicing today is that extra step at the end. We're not just solving inequalities, we then have to determine what the largest or what the smallest integer value could be. It depends on the question. All right, so I already got a head start here by drawing my train tracks and underlining the question to begin. Now I'm gonna start solving. If I look at the left-hand side, I can see that looks pretty busy. I wanna combine like terms. My 6x and my positive 6x can definitely go together. 6 plus 6 is 12, so now I have a 12x. I bring down my plus 2, and I bring down the 14. I don't have any more like terms, so now I have to go to the opposite side by using the opposite operation. The opposite of adding 2 is subtracting 2. So all I have is a 12x on the left, 14 minus 2 is 12 on the right. Last but not least, a number and a letter together, they're mushed. Mushed is multiply. The opposite of multiply is divide. So I'm going to divide both sides by 12. This cancels. So I get an x on the left. 12 divided by 12 is 1 on the right. And now I have to ask myself, did I divide by a negative? Nope. So this inequality will stay. X will be less than 1. But I'm not done. I have to determine the largest integer value x can be. So again, if drawing a number line helps, I would totally do that. So let's do that quickly here on the side. I'm going to put my solution on the number line. 1 is an open circle. It is not included. And I'm going to shade to the left. So here we go, to the left-hand side. All right? So since 1 doesn't work, I have to ask myself, well, what number is less than 1? Because I'm going to the left, those numbers should be getting smaller. Well, on a number line, to the left, I would then have 0, then I would have -1, right, so on and so forth. But we had gone over in the do now that the trick, if this is not the answer, you just follow the arrow to the next available number, which would be 0. So what's the largest integer value? 0 is the largest integer value. All right, again, make sure you're writing out this little blurb. If you're not, you technically have not fully answered the question to earn that full credit. Okay, let's look at 3 and 4. Number 3, same thing. You want to draw your train track and you want to underline the question to start. Okay, if I look at the left-hand side, these are both like terms, so I can combine those together right off the bat. So I have a -p and I have a -4p. If this helps you, I know it helps me, I'm going to put that invisible 1 in front of, oops, I'm getting all blurry here. Okay, we're back. I'm going to put that invisible 1 out front, so I know this is really a -1p, and again, that's a -4. So in the calculator, you would type in -1 minus 4, and you would get -5. So we have a -5p on the left. I have a -10 on the right. All right, anytime I have a number and a variable mushed together, mushed is multiply, so the opposite of multiplying is dividing. So I'm going to divide both sides by -5. That cancels out. All I have left is a p. -10 divided by -5 is +2. And now I have to ask myself, did I divide by a negative? Ding, ding, ding. I absolutely did. So I'm going to change this from greater than to less than. So p is less than 2. But that's not the question. I have to determine the largest integer value p can be. So now I'm going to just draw a quick number line. I'm going to put my solution on it. This is not included. That means it gets an open circle. My arrow points to the left. So again, I'm going to shade to the left-hand side. Well, since 2 isn't included, I have to ask myself, what number is less than 2? That's going to be my answer, that next available number. Well, on a number line, I know 1 comes before 2, right? I'm getting smaller. 2, 1, 0, on and on. So if 2 isn't the answer, that means 1. 1 would be the answer. So determine the largest integer value. 1 is the largest integer value. All right, let's practice one more, and then I'm going to have you guys finish this lesson on your own. So if we look at number 4, same thing. This one looks a little bit tricky, but it's actually not that bad because you guys are so good at this. We've practiced it so many times. Whenever you see parentheses, I know we think to multiply, okay? So I want to look at that coefficient, that number that's right in front of the parentheses. I can see it's a number 5. So the first step is to multiply, or really to distribute that 5 to all the neighbors that are inside parentheses. 5 times 6 is 30. 5 times 3r is a positive 15r. That plus 7, he just comes down for the ride. And on the opposite side, I just bring down that 127. Now I go back. This looks pretty busy, so I'm gonna look for like terms. Well, 30 and 7 I can always put together because they're numbers. 30 plus 7 is 37. I bring down that positive 15R, and I'm also gonna bring down the 127. All right, I don't have any more like terms, so now I'm gonna go to the opposite side, and I'm gonna do that by using the opposite operation. If the variable is on the left, that means I want my numbers on the right. So the opposite of a positive 37 is a negative 37. All right, so I'm really just subtracting 37 on both sides. I bring down my 15R. 127 minus 37 is 90. All right, and then last step, whenever you have a number and a variable mushed together, mushed multiply. So the opposite of multiplying is dividing. Divide both sides by 15. On the right-hand side, I have R. On the left-hand side, 90 divided by 15 is 6. I did not divide by a negative. I will not change the inequality, so it stays. And then again, what's the smallest integer value? I'm going to figure that out by drawing a little number line here. I put my solution on it, which is 6. This will be a closed circle that's greater than or equal to. So I can be 6, or I can be greater than 6. All right, so I got to fill that in. So this is different than numbers 1, 2, and 3, because since 6 is closed, 6 would be the smallest integer value. Write that down. 6 is the smallest integer value. And again, that's because 6 can be a solution. It's included on the number line, so I don't have to look any further than the number 6. All right, you guys are gonna try 5, 6, and 7 on your own. Once you're done, come back and check the video. So at this point, you need to just press pause and check back. All right, here's the solution to number 5. This one was a little tricky because at the end I divided by a negative. So since I am dividing by a negative, I am going to switch that inequality around. So it's not less than or equal to, it's greater than or equal to, okay? And then again, since it can equal negative 3, that means, negative 3 is the smallest integer value. All right, so that was number 5. Here is numbers 6 and 7. All right, here we go, 6 and 7. So number 6, I did not divide by a negative, so I did not need to change the inequality, okay? Depending on how you solved 6 is gonna depend on what side of the inequality K is on. When I solved, K was on the right-hand side, and that's ugly, right? We wanna switch that around. That's not normally how it looks. So if I'm swapping K and 7, right, I swapped them around, that means I have to turn that inequality around as well. All right, I know that in previous lessons, you guys have learned that this looks like a shark, and you want the shark to eat the number. So the same thing, the shark is still eating that number. So however you can remember it is up to you. If you need to turn it around, K and 7, I had to swap them, then that means you have to swap the inequality as well. All right, and then number 7, I ended up not having to divide at all in my last step, so I didn't have to worry about switching, anything. So I should have had P is greater than 3. What's a number that's greater than 3? 4. So 4 would have been the largest integer value. All right, make sure you guys get the closure done and you get that homework done. Submit everything on Canvas.